I am the nature hacker, and this is your world. So today I want to teach you how to make hydrobromic acid. This is a stronger acid than hydrochloric acid, but it's non-oxidizing, just like hydrochloric. You know, it's not like sulfuric or nitric that's oxidizing. It's basically neutral in the oxidation reduction department, which is perfect for what we're doing with noble metal batteries. So what we want is just an acid that acts as a catalyst, and then we'll have some air in there that's acting as our oxidizer. So as soon as the air stops, the battery chemistry stops, and the battery can be stored safely without reacting. So hydrobromic acid, very great potential in battery research, has the potential to be better than hydrochloric. So today I made 63% hydrobromic acid, and the biggest hydrochloric you can buy off the shelf is 37%. This is 63%. Almost double the concentration. Not only is it a stronger acid, but it's a much higher concentration there. So how did I make that? Well, I'm going to give you the recipe right here. I made up this recipe, so this is the Nature Hacker method. 61.3 milliliters of 85% phosphoric acid. It has to be 85% phosphoric acid. A great source is Duda Diesel. So just Google Duda Diesel online. 61.3 milliliters. Alright, 61.3 milliliters. And then 102.9 milliliters, 102.9 grams of sodium bromide. Sodium bromide, this stuff. Okay. So 102.9 grams of that. Alright, so 61.3 mils of 85% phosphoric acid, 102.9 grams of sodium bromide. That's it. You put that in a reaction flask and you distill that. You just heat it up, distill it until it's basically dry inside your reaction flask. And so the theoretical amount of water in that phosphoric acid was 33.5 milliliters, and that is 15.5 milliliters as that 15% weight of water. So it's 15.5, and there's also 1 mole of water in the H2PO4. You get the H2 and one of the O's, it turns into water, so that turns into PO3, so that turns into sodium phosphate or something, sodium phosphite, I believe. So so you get the 18 mils of water from the molecule itself of phosphoric acid. You get 15.5 mils just from the dilution. So that's 33.5 milliliters of theoretical water. And so my yield, once I distilled my 61.3 mils of phosphoric acid, 102.9 grams of sodium bromide, I got 31.5 mils, which is only 2 mils was I missing, and it was probably just still my reaction that I didn't get my thing hot enough to get that out. I was cooking it about 200°C just at the smoke point of canola oil, because I was using an oil bath. So I got 31.5 mils of liquid. So that's this right here, 31.5 mils. And that weighed 51.75 grams. Now, before I go into my concentration, I just want to say off the shelf, the biggest concentration of hydrobromic acid you can buy off the shelf is 48%, and that's 1.49 grams per mole. Well, mine turns out to be 1.643 grams per mil, and 63%. So I'm a good 15% higher than the best off-the-shelf stuff, and that off-the-shelf stuff for 100 mils is like $100. So this would be the equivalent of like $30 online for 48%. This is 63%. So this would be like $200 worth of acid right there, and I made it for like $5 of this and about $1 worth of phosphoric acid. So for about $6, I made a couple $100 worth of acid there. So yeah, 63%. And so I tried doing this. I added some water in one of my tests. I added 50 mils of water to the reaction mixture that I said before, the 61.3 phosphoric acid, 102.9 sodium bromide, and I actually lost, obviously I got a dilute acid. I got 22% concentration of acid, which is really crummy. But I also lost 10% of my yield. So doing it just with the concentrated phosphoric acid and adding no water gives you a better yield than adding water. So you don't want to add any water to that mixture. The only other option to do is maybe adding more phosphoric acid. Maybe if we add more phosphoric acid, we get, well, obviously we'll get more liquid, but maybe it will be the similar concentration, but just more of it. So it's worth trying to increase the amount of phosphoric acid you use. And if increasing the amount of phosphoric acid you use doesn't improve the yield and just makes it more dilute, then what we could try doing is, going back to this original method that I came up with, 61.3 and 102.9, and then adding some calcium chloride to actually reduce the water even further, so we get it even concentrated, more than 63%. So there's that possibility. I think I remember reading somewhere that the maximum amount of HBr that's soluble in water is 65%, so maybe we're close to the limit anyway. And maybe, dehydrating the reaction mixture won't help at all, but, it's worth trying. So a couple more trials that I'll have to make anyway, but anyway, here's that's the method right there, just that really basic 61.3 phosphoric acid, 102.9 sodium bromide, distill it, and you got 63% hydrobromic acid. Thanks for watching. This is the Nature Hacker method. I am the Nature Hacker. Do work.